an electron is an electron is an electron. It doesn't know if it's an S or a P. Oh, so look at this. So group 1, okay, is going to bond over here, okay, with which one of the P's? P1, 2, 3, 4, 5. Oh, it's going to bond with group 17. So group 1 bonds with itself and group 17. Oh, well, what's in 17? Oh, well, 17 over here is fluorine, chlorine, bromine, iodine, and acetine. Oh, that's kind of cool, because then we have hydrogen over here. Oh, we make acids. Hydrofluoric acid, hydrochloric acid, hydrobromic acid. Oh, but then we have sodium here. Oh, sodium chloride, sodium bromide. Oh, so now we're starting to hear some things that make sense. But that's everything that group 1 bonds with. It either bonds with itself, or it bonds with group 17, or it's not stable. Oh. So you're telling me if I put hydrogen with a carbon over here, I better have something else or something's going wrong? Yeah, that's exactly what we're telling you. Oh, okay. Well, that's kind of crazy. And once again, I know your head's spinning, okay? I know your head's spinning. But remember what we want to make, S2s and P6s, okay? So now, let's take group 2. We don't worry about the transition metals, so everything in 3 through 12 we don't worry about, okay? So group 2, okay, what does it bond with? Well, it's an S2. So it doesn't bond with itself, because that'd be an S4. That's no good. So group 2, oh. So what do we got to get a P6 once again? So how many electrons plus 2 equals 6? Oh, that'd be a P4. Oh, so that's going to equal a P6. So what group? So I want to say now, what group is P4? Oh, well, look how chemists have it. There's my S's sticking up. There's my transitions down low. Oh, there's my P's. 1, 2, 3, 4. Oh, the oxygen group. Okay, the oxygen group. Okay, so there's 18, 17. Oh, group 16. So group 2 plus group 16, okay, see that's group 18, 17, 16. Okay, now did you see where I got where it was a P4? P1, P2, P3, P4. Oh, so you're telling me that beryllium, magnesium, calcium, and barium and radium, all of these bond nicely with this group right here. That's exactly what I'm saying. Oh, so if calcium bonds with sulfur or oxygen or selenium, I'm okay. Yeah, that's what I'm saying. That's stable. Oh, if it makes an S2 or a P6, it's stable. If it bonds with anything else, it's not stable. And we'll talk about how we've got to adjust that to make it stable. Okay? So now, let's go to group, let's go over here. Okay? So once again, so we got group 18, 17, 16, 15, 14, 13. Okay? So 13, group 13. Okay? That's a P1. Okay? And what does group 13 bond with? Well, it bonds with group 1 because that would be an S1. And since it doesn't know if it's an electron, that makes an S2. So it bonds with group 1. But what else does it bond with? Okay? It's a P1. So a P1 plus what's going to equal a P6? A P5. Oh, cool. So P1 plus P5 equals P6. Because remember, we want, what do we want? S2s and P6s. So which one is P6? Well, there's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Wow. Okay. P1, P2, P3, P4, P5, P6. Wow. But I've got a problem. Okay. All right. But I've got a problem. Okay. A P1 and a P5. Actually, let's see. P1, 2, 3, 4. P5 right here. So group 17. Okay. So that's fluorine, chlorine, the same one that group 1 bonded with. Okay. P1, 2, 3, 4, 5. The fluorine group. And once again, if you're watching this for the second time, be sure you have your periodic table out. Go through and watch this a couple of times and you'll have it. So group number 13 bonds with 17. Okay, so group 13 bonds with 17 to make a P6. Cool. Okay. All right, now let's go into the next step. Okay. Now let's make Lewis dot structures. Now in a Lewis dot structure, now this is where it's nice to have chemistry, S-T-R-E-C-T-U-R-E. It's nice to have chemistry going into this, but you sure don't have to have Okay, if you understand what we're talking about today, it gets you caught up. Now, let's draw carbon, for example. Okay, now in a Lewis dot structure, we put the symbol. And whatever that symbol is, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 places for electrons. 8 electrons is the most it can have. It's called the octet rule. When it has the octet rule, says that when I have 8 electrons, I'm as stable as I can be. I can't be any stabler. All right? Now, so let's look at carbon. So what does carbon have? Okay, what does carbon have? Come on up here, Mr. Cameraman. Okay, so what does carbon have? Well, let's look at carbon. So now I look at the whole period. So here's carbon. Okay, well, what do I have? See, look at this period that runs all across. I have an S1, I have an S2, and then I have a P1 and a P2. So carbon has S1 and S2 and a P2. So yeah, let's see. See, carbon has 1, 2, S1, S2, and then P1, P2. So how many valence electrons does carbon have? It has 4. Oh. So what does that mean? That means it has 1, 2, 3, 4. Now, this depends on where the electrons fall, because this is gunpowder. See how all those electrons are by themselves? They're all unpaired. Oh, we said carbon has 4 bonding sites, 4 places where it can bond. Or how about this? Okay, so this is gunpowder, all right, and this is carbon that we put in your motor oil that doesn't break down. Wow. So whenever we have an X that's paired up, that's not paired, it can pair with something else. Oh, well now let me tell you a nice deal. Okay, so everything in group 1. Okay, now here we go. You should have got your ears on now. Group 1 has 1 valence electron. Why? Because it's S1. Group 2 has 2 valence electrons. Why? Because it's S2. Now we skip 3 through 12, okay? We skip because it's transition metals. We'll talk about that later, okay? So we go all the way to group number 13. Now, group 13 is kind of cool. Has an S1, an S2, and a P1, so it has 3 valence electrons. 14, oh, that's kind of cool, that's carbon. It has an S1, an S2, and then 2 Ps. It has 4 valence electrons. Oh, well, look what we got. Look what we got. It's kind of neat. Chemists had this. It turned out really cool. So 1 has 1, 2 has 2, 13 has 3. So the T number tells us how many valence electrons. 13 has 3, 14 has 4. How do you fit? What do you suppose 15 has? Nice. Wow. 15 has 5 valence electrons. V-A-L-E-N-C. Okay. So 5 valence. And then 16 has 6. 17 has 7. And 18 has 8 valence electrons. Nice. Now, I don't know if you picked up on that, okay, but 18 is kind of interesting, okay? 18 is kind of interesting because when we find 18 and we draw the Lewis dot structure, like let's take neon, for example, and it's in group 18. Now, the one exception is helium. It only has 2, but it's full because of the S2, okay? So neon, if we want to draw the valence dot, the Lewis dot structure, 1, 2, 3, 4, 5, 6, 7, 8. Now, wait a minute. So is there a spot that it can combine with anything? No. Group 18 is called the noble gases. They don't bond with anything. That word comes from nobility because if you were noble, if you were a prince or princess, you could only talk to other people who were prince or princess. You couldn't associate with somebody else. You couldn't associate with somebody else. That's why Princess Diana was so famous, because she was a common everyday person that her husband, Prince Charles, I can't keep up with this. Okay, so that prince found an interest in, well, she wasn't nobility. That's why she was so famous. It hurt her because the paparazzi chased him around so much. But noble means doesn't bond with anybody. So what bonds with group 18? Group 18 bonds with nothing. Nada. Group 18 solid. Noble gases. Can't be broken down. So, what does that mean? Well, that means it's interesting because argon is in the air. We're going to talk about that when we talk about breathing. So, is that good or bad that argon's in the air? Is it good or bad that it's a noble gas? It's good. Because as we breathe in the argon, it doesn't bond with anything. So when we breathe in argon, it goes through our lungs and it comes back out argon. Oh, cool. So a noble gas doesn't bond with anything. So like, oh, that's bad. No, it's good for human anatomy. Okay. So now, let's go one step further. You know what? I think I'm going to stop there for a little bit. We'll stop this video and give you a chance to re-watch it, and we'll pick it up with the next one.